And we have a very good topic. I'm excited to introduce David Rowe. And I want to read David's biography here because I think it's important that we know who we're hearing from, his background here. He has 20 years experience in the development of DSP-based telephony and SATCOM hardware and software. We would never have guessed that. David has a wide mix of skills, including software, hardware, and project management, including a PhD in DSP theory. Again, something we just did not know about you. He has held executive level positions in the SATCOM industry and has built several successful small businesses. In 2005, David founded the Free Telephony Project. Go to www.rowetel.com, which has pioneered the field of open hardware embedded voice over IP products. His open source contributions include the first open telephony hardware drivers in 1999 and the OSLEC Echo Canceller. David's other interests includes building and advocating electric vehicles and voice over IP technology for the developing world. And do electric vehicles and voice over IP go together? Okay, so we'll hear about those next year, right? Okay. I'd like for everybody to give a warm welcome to David.
Thank you. These slides, by the way, are some pictures of a camping trip from Southeast Australia that I went on earlier this year, just in case you're wondering. Someone said they were slides, could have been Texas until the one of the kangaroo came up. So I'd like to talk about a project called the Village Telco that I've been working on with a group of people for the last 3 or 4 years. The idea of the Village Telco is to help people in the developing world make phone calls at an affordable price. And as I go through the presentation, you'll see a lot of parallels with ham radio technology and ham radio philosophies, things like helping out people, community service, open hardware, sharing designs. So I'll start by describing the problem. Why do we need to look into telephony for the developing world? Talk about the Village Telco project, a piece of hardware called the mesh potato that we developed especially for the project, and the first real-world deployment of the Village Telco technology, which is called the Dili Village Telco. Dili is the capital city of a tiny new country in Asia called Timor-Leste, or you may have heard it called East Timore. So why do we worry about telephony? When we think about the cities of the future, you get visions of the Jetsons and shining spires, but in reality, the cities of the future are probably going to be slums. Urban to rural migration in places like Asia and Africa mean people are going from country villages and they're settling in places like this. This is, I think, Kibera in Nigeria. 1 million people live in conditions like this. And this is only increasing. At the moment, about 30% of the world's population who live in cities live here. It'll be 50% within 20 years or so. So we're interested in how they communicate and how we can improve their lives with communication. A lot of people already in places like South Africa live in cities like this, and that inspired the founder of the Village Telco project, a guy called Steve Song, to start the Village Telco project. The problem in a lot of developing countries is that mobile phone calls cost too much. There are no landlines. Most of these countries started out 10, 20 years ago. The first telephone anyone saw was a mobile telephone. So you've only got mobiles. Usually they're prepaid credit, and they tend to charge the sort of money they charge in a first world developed country like here or Australia. But of course the people there earn much less money. So proportionally, very expensive phone calls. One example from a country that I'll talk about later on is 25 cents a minute for a phone call, but the average income is $1.52 a day. So, would you make a phone call if it cost 2 or 3 hours of your daily wage? The telephone companies there tend to be a little bit predatory. They'll have schemes where they'll sell phones very cheap. They'll sell $1 prepaid credit cards to get people started and addicted to it. Sometimes there's cultural issues, like you're expected to hand the phone over to your friends or family culturally, so the credit gets chewed through very quickly. So it's a real problem. And what people end up doing, rather than making a phone call, is they might send a runner out to deliver messages to people. It's just cheaper. because this person might be earning a few cents a day and they'll deliver a message around town with runners or send people driving around in cars to deliver a message, where we just pick up a phone or send a text message. So I guess at the Village Telco project, we believe that a phone call should be a human right, not a privilege of the rich, which it is in many countries. So in 2008, a bunch of people got together. The guy who started the project is called Steve Song, up here. He had a three-year fellowship with some place called the Shuttleworth Foundation in South Africa. They're the guys who are behind Ubuntu Linux and a few other projects. They sponsor people called Shuttleworth Fellows to try and give them a budget and try and work to develop things to make the world a better place. Steve's brief was to come up with better telecommunication systems. So he gathered a bunch of us from around the world that had been involved. I'd been involved in VoIP and open hardware work. Other people had been involved in deploying Wi-Fi systems in the developing world. And what Steve wanted to come up with was a system that we could roll out small phone companies into villages and towns in the developing world and build phone systems to give people inexpensive phone calls. Now, because we'd all worked in the developing world before, we'd all experienced some of the problems in the developing world. And I'm going to give you a first-person account of that later on. But the ground rule is about 20% of what works in the first world will work in the developing world for various reasons. Being technologists, we try and solve these problems with technology, build a better piece of hardware, better modulation, better coding. In reality, about 80% of it is actually human factors and social issues, which I'll also talk about later on. It's not always the technology. And that can be a trap when you're an engineer and you like playing with technology and you think everything can be fixed with technology, as we found out. So the idea of the Village Telco is in a variety of homes around the village, we have a little box. And that's a Wi-Fi box. It just sits at rooftop height. Connected to that box is a regular landline telephone, just a regular telephone handset. And via these Wi-Fi boxes, you get a landline delivered to your home. Now, unlike a cell phone system, there's no central cell phone tower that you communicate to. Each of these homes communicates to the next one and the next one and so on. It's a mesh network. So your phone call is carried by your neighbour's box, which carries it down the line. And after 3 or 4 hops, it might hit its destination or it might hit a gateway, which allows you to connect your phone call to the rest of the world. The idea is to use regular Wi-Fi technology, open source software, and some special hardware that we developed, which I'll talk about in a moment. Now, we're trying to build, in this case, small-scale telephone systems up to 500 devices. You can start with just 2 to talk to each other and up to 500. The immediate application was the townships of South Africa. So this is how it would work. This is a picture of one of the townships in South Africa, which is sort of very high-density slum-type living conditions. So we have the boxes on each roof, and they mesh with each other. And they have software built in that automatically sets up the mesh network. If you want to ring the guy down the road 1 kilometre away, it'll work out which path is the best one to take. And it does that automatically. If someone else's box falls over or breaks or the power goes off, it reroutes the calls automatically. And that's done with software that's used for mesh networking of internet traffic. So the difference with mesh Wi-Fi and regular Wi-Fi is that it's all peer-to-peer. The nodes talk to each other. Your regular Wi-Fi with the access point has a central access point and all messages must go through that. So that's how most Wi-Fi works, but what we're using is this mesh Wi-Fi. No access point with mesh Wi-Fi. One of the advantages of that is extended range. In this case, all these nodes can reach the access point directly, but node C can't. However, node C can see D and B, so with a mesh network, it can relay its message through the network. And you can get extended range and extend this off indefinitely. So that's a little bit about some of the mesh Wi-Fi technology, but the other important part was what we're trying to build here is a small telco business. In the developing world, a lot of technology projects are funded by grants. So a well-meaning first world organisation comes into a developing country. Consultants like me turn up, get flown in, have to live in hotels that are expensive by local standards, get paid a lot of money to be there, set up some technology, train, and then we leave. And usually about a month later, it all falls over because the local guys haven't been trained enough how to use it. There's no continuing business model. There's no funding coming in. And this problem we see time and time again in the developing world. So what we decided to set up was a business around this. How can we make a small telephone business, a real telco, where some local guy in a village who's got what we call a reasonably geeky entrepreneur. You know, someone who knows enough to, you know, sort of skills we'd have in this room, set up a Wi-Fi system, maybe play around with a Linux computer, but not someone who needs a PhD in Wi-Fi technology to set it up. So a local guy with modest amounts of capital, and these sort of people exist, you know, with something like $5,000 capital, could set up a business with a couple of hundred of these mesh devices around town and start selling phone calls at a modest price and use that to sustain the network. So having a small business around it enables the system to grow virally, because we're using, you know, capitalist techniques to grow it rather than philanthropical techniques. We also want it to be scalable up and down from very small networks to very large networks. Most cell systems, there's a minimum that you can install. You won't see cell phone towers in small villages because it's not economical to put one up with all the infrastructure and hardware you need. So the idea of the Village Telco would be grounded in business, not technology or charity. And so it's using business to help people in the developing world. Just comparing the competing technology, cell phones, the mobile phones, they have a very wide coverage in the developing world. Most of the world can get cell phone coverage, it's just they can't all afford it. So it's useful to compare the Village Telco technology with cell phone technology. One is call cost. This essentially has a free local call cost, or you can have a small amount to fund the business, or you can decide just to charge for long distance calls into the regular networks. But it can be as cheap as free if you wish. Whereas mobile phone calls tend to attract profit-seeking, very high profit-seeking business models. It's a community approach. You rely on your neighbours to send your phone call around town. So it promotes some sort of community action there, and that works really well in a lot of these developing world communities where the village ethic is still very strong, and a lot of them might be related, you know. So, you know, you get your uncle and your cousin and all these things as part of the phone network, and because you're relying on each other, there's a tendency to help keep it working and maintain it. This uses unlicensed spectrum, which is good for a lot of points of view. Many countries getting a spectrum license for any radio service is nearly impossible. But most of them support Wi-Fi, and that's where we're using. The downside, of course, is because we're sharing Wi-Fi spectrum with everyone else, interference from other services, and we have encountered that problem. But if you're in the middle of nowhere, setting this up in a village for a local call network, then usually the spectrum's pretty free, and you won't get interference. The infrastructure cost for this system is very low because it's peer-to-peer, there's no cell phone towers, so you don't need a big cell phone tower or a generator or all that infrastructure. Cell phone networks, as I said, don't scale down to very small village levels, and the capital involved. These devices cost less than $100 each, so for a few $100s you can start building your phone network. You're talking about a minimum of $50,000 to $100,000 for the smallest cell network. This also brings out some ideas that I guess we're trying to promote. A cell phone network is a really locked-in, closed network. You can't go and add a server to a cell phone network like you can to the internet, for example. There's really strong licensing on cell phone networks, whereas the internet, it's all open standards, unlicensed, anyone can connect. Think about the cost per bit over the internet. If you send an email, it's virtually free. We get DSL plans where you get gigabytes a month for a very low cost, compared to what it costs to send a text, where you're probably paying, you know, a cent a character on the average text message. So much cheaper, these internet-based networks. There's that idea of community ownership versus big business or government. We're looking at building community-owned telephone networks as distinct from ones that are owned by big business or in particular government in the developing world. Another idea I'd like to mention is that in development projects, a lot of really good projects have been ruined by money. It's just like it's not technology, it's not just throwing money at the developing world. You've got to have systems around it that match the local culture and that will be promoted without constant injection of funds. And voice is the killer application. The reason is literacy. Many people in the developing world simply can't read. So if you give them internet connection, they can't use it, especially the older generation. But everyone can use a telephone. One of the things we needed for this was some specialised hardware. We needed to combine something called an analogue telephone adapter. And what that is, you might have one at home for getting cheap VoIP calls. You plug a telephone in one side and the internet or an Ethernet cable in the other side. ATA or analog telephone adapter. We wanted to combine that with a Wi-Fi box, but we couldn't buy exactly what we needed off the shelf. There's a lot of people doing work with Wi-Fi in the developing world, and typically they have to buy off-the-shelf hardware that might not be quite right. Well, we decided to build our own product to do this. So we decided to do a full custom design of a router, and make it especially for our project and especially for the developing world, and then put that into production rather than just buying off-the-shelf hardware. The device we called the Mesh Potato. The way we got the name for that was when we put the acronyms up, we had POT for plain old telephone and ATA for analog telephone adapter. Which is patata. We had a Spanish guy with us, and he realised that was potato in Spanish. Hence we got Mesh Potato. What it's really doing is it's a box that delivers a landline via Wi-Fi. It sits up on top of your roof, you can see some other devices within a kilometre, a few hundred metres away, and it forms a mesh network with them. The target price we've got is around US $60. We're not quite there yet, but it's early days. We think we can get it down to that. It's fairly unique in that it's an open hardware commercial product. So we publish the designs, we're blogged on all the development. There's a lot of information out there on how we build it. It's a real volume produced product. We have a Chinese mass manufacturer who build them for us, but it's custom designed for the developing world. And some of the things we did was something we call Africanization. We had a lot of people with field experience of building hardware in the developing world. Now, if you buy a $60 router and send it to somewhere in the developing world, it'll probably cost you $200 to DHL it there. Because it'll be in the middle of the nowhere, it'll be impossible to get there, it'll take weeks. If it breaks, it costs a lot more to get it back there than the capital cost of the router. So for the cost of a couple of parts, we can make the thing a lot more robust. Some of the problems you get in the developing world are rough handling. A lot of people don't really understand technology and how to treat it delicately. You see things like computers lifted into the second store using the Ethernet cable as the rope. They use that to hoist it up. We've set reverse polarity on DC connectors, 240 volts connected to the DC connector. Power is notoriously bad, undervolt and overvolt. You can have your AC move from 110 to 240 or 350 volts, just as the load comes off and off the network, off and on the network with very poor regulation. A lot of the developing world is in harsh climate areas, so you've got humidity that corrodes things, rain for weatherproof devices, hail, connector corrosion, things like that. So another issue is lightning in tropical areas and protection from lightning and ESD. So these things can be, when you design and manufacture a device, it costs a few cents to add the components to protect a device that might save several $100s of replacement in the field later on. So we decided to add those components, as well as things like efficient power supplies, so it can be run off solar panels and not need AC power if it's not available. We call that Africanization, just making it tough for the sort of conditions we had encountered in African remote communities. Then we just started building it. We started with an off-the-shelf router. This is a NanoStation 2 from Ubiquity, and this is just an AVR development board. And what we did was we took a regular Wi-Fi router and worked out how to make it do VoIP on the same board, voice over IP. And that was by adding some chipsets for connecting to a telephone, using a microcontroller to interface, and some open source software. So we basically combined all the ATA functionality, all the telephony interfacing, voice compression, echo cancellation. That all went onto the router. We used that to work out our basic design, and then went into production with a full custom device. We also developed an internal antenna for the device, so we did a bit of work with microwave antennas. Just the simple Omni antennas. With a mesh network, you don't really want a directional antenna because you want to be able to see other devices in the network from any direction. But what we want to do is get the price right down, and it had to be an internal antenna for the reasons of weatherproofing. So we came up with a simple printed circuit board, and that's a quarter wave vertical for 2.4 gigahertz. That's one of the prototypes we tried, as well as some other wire-based antennas. We had a lot of fun developing and testing those. And very easy to manufacture, just a little bit of PCB track on the end of the PCB. And that's roughly the same performance as the little rubber ducky antennas you have on your home routers. So this was the end result. This is a little girl in a community called the Bokap in Cape Town. It's a Malaysian immigrant community, and we use this although it's pretty much a first or second world suburb of Cape Town, we use this as a demonstration area because it had great terrain for Wi-Fi. It was a nice sloping hill going down, so everyone could see each other. And a lot of the people know each other because they're a migrant community. So the idea of having a small telephone network where they could all talk to each other was very appealing. This little girl is our phone model, and that just shows the mesh potato that we ended up developing in its weatherproof enclosure. Now, they're normally not mounted on little girls. We normally stick them to a wall or a mast. This is one that's mounted just indoor. This is a window sitting next to it, but it just goes through the window and out to the rest of the world. Or often they'll be mounted on a short mast on top of someone's village home. So the next step was to try this thing out in the real world and find out how many of the assumptions we made when designing the system were wrong, because that's what normally happens. So we had to do the beta testing. We secured a grant to test the system in a place called East Timore, or Timor-Leste is the local name for the place. This is the first real-world deployment. It was a partnership between a local group called Fongtil. Fongtil are like an umbrella organisation for NGOs, and they handle IT for a lot of NGOs in East Timor. And that's quite handy because they know all the IT guys, and we had plenty of guys we could work with to test our product. And it was a partnership between them and my consultancy. So where is East Timor? This is the top part of Australia, and East Timor is half of the island of Timor, which, and this is Indonesia above here. That's about probably 300 miles long at the top, and population about 1.2 million, but it's growing at 10% per annum. A very high birth rate. One of the poorest countries in Asia, and unfortunately the poor country usually goes with the high birth rate. And it's a country that's had a very, very difficult past in the last 400 years since colonisation, and in particular the last 25 years. This is my partner, Lemmy Saws. He's a Timorese guy from Fongtil. He has a team of guys who work for him, who are doing IT. Here he is playing around with one of our prototype meshed potatoes with a homemade directional antenna made out of cardboard and alfoil. That's about 12 dB gain. It works quite well. I'm just going to tell you a little bit about his story, because I want to put it in picture of what it's like doing IT in the developing world. We're used to, being able to go down, buy any bit of electronic equipment we want. The power works most of the time, and we're not in any physical danger. Normally there's no one shooting at us. This guy's seen it all. So I just want to tell you a little bit about his history and his motivation for working on this sort of thing, because it's what motivates me to work in the developing world and help these guys out who've got it a lot worse than we have. So Timor was a part of Indonesia until 1999. Indonesia annexed the country in 1975. Prior to that, it was a Portuguese colony. At the time of annexation, it had one high school in the entire country, and very poor country. Lemmy studied IT in Indonesia. That's what you had to do. You had to travel to Indonesia to travel. And he started getting involved in the Timorese independent movement in 1996. He wasn't very popular. The Indonesian government took a poor view of independence for quite a while, and Lemmy found himself being chased by the Indonesian police and army, and had to seek refuge in the Polish embassy to avoid going to jail, and had to spend 4 years thrown out of his own country in Portugal as a political refugee. Then he returned to the country in '99 when the Indonesians withdrew. When they did withdraw, there was a lot of civil unrest. There were militias that went around burning everything. Most of the infrastructure, hospital, electricity, schools, universities, anything of value was burnt to the ground, and the country was left with nothing. People starving, and a lot of people died. So what's happened since then is the country's been trying to rebuild itself. The US Army, Australian Army went in to restore order. There's a big UN presence there. If there wasn't, they'd still be shooting at each other. But slowly they're developing things. And so Lemmy, his motivation is he wants to help his own country develop. The general population, no one knows how to use a computer. There just isn't that penetration. Very little networking or IT knowledge, how to set up an IP network or anything like that. So Lemmy's working for he has a few of these skills. He's working for the Fongtil, which the English translation is NGO Forum. They're an umbrella organisation for NGOs that he helps. If the NGO down the road, the women's rights NGO, has trouble with IT, these guys will go down and help them fix it. And he's also been doing a bit of work with Wi-Fi and voice over IP training in the country. His main motivation is to help his country develop, very similar to what we'd all have under the same circumstances. The sort of problems you get in the developing world, bandwidth is a killer. You can just about get an email in and out of the country, but some of the time. The bandwidth is so poor. Try to do Skype or any sort of real-time communication, it's really bad. Viruses are a huge problem because all the software is pirated. So every computer is full of viruses and clogs the network even more. No one has the skills to de-virus computers. Power goes off for days. You're sitting there working and poof, it goes dark, the fans stop turning, and you're just sitting there for 3 or 4 hours, and these guys they're used to it. They just take it in their stride. But for someone who's used to working with electricity 8 hours or more a day, it drives you nuts. You know, the laptop battery lasts a few hours and you don't know what to do. But that's just life here. The power's intermittent. Very little local expertise in things like Linux command line, for example. There'll be very few people who know that. Relative cost. As I said, the income's very low, so even a cheap piece of IT equipment is expensive for them. If you can get it in, the local mail service simply doesn't work unless your cousin works at the mail office. You're not going to get that package out the back for months. So then you have to use couriers, which cost 2 or 3 times as much as they do in the developing world. So really hard to get anything done IT-wise. There's this problem of what happens when the foreigner goes home. And the first time I went to Timor to sort of see what I could do to help, they had a bit of a go at me because they said, you guys come all the time, you make all these big promises, you're here for 2 or 3 weeks and you get back on your jet and go home and everything breaks. And I said, oh, hey, whoa, you know, what's going on here? So I spent a lot of time investigating why that is. And, you know, that's one of the key issues. We've got to, as technical guys, we want to go there and help, but we've got to really understand the non-technical issues like training, making the technology easy to use, making sure the local people can repair it, because it's a really corrosive atmosphere or process to go through just with money and just with foreign consultants to try and fix things up. We've got to take other approaches. So in short, making anything work in the developing world is really difficult. So the goals of the Village Telco were to train the Timorese to install the network, install 100 mesh potatoes around Dili, and try and build a local call telephone network. My consultancy provided training. We got all the equipment organised and shipped it in. And for example, we bought a lot of cables, connectors, soldering equipment, about $2,000 worth. It cost us more than $2,000 to ship it from Australia into Timor via THL than the stuff we bought. That's one sign of the problems, just shipping. Now the idea was that the Fongtil and the Timorese guys would perform the installation and then they would run and maintain the network. And then we'd see how it went for 6 months. So the first step was to do some training. This is a group of young IT ladies who've been trained in IT. These people usually recycle Australian Office PCs. They put Ubuntu on it and then resell them for $100 or so in the local villages. That's their sort of day job, but they were interested in this technology, and they're operating in you can see a corrugated iron shed, which is actually a really nice building by Timorese standards, well ventilated and new, and they're training to use the mesh potato. So one of them's got the analogue phone connected, and to configure the mesh potato, we've made it really simple. You just hook a PC up to it. There's a simple web interface, and you have to set one number, which is the telephone number. And then you power cycle, and it's ready to make phone calls. So it takes about, with all the training we do a bit of training on recovery, what happens if things go wrong, but it takes about 2 or 3 hours to train someone to be able to install mesh potatoes and set up telephone networks. And that's what these ladies are doing here. We included a little bit of local assembly. At the time, we didn't have the production mesh potatoes in the outdoor weatherproof case, so we took the beta versions, which were just the PCBs, bought some off-the-shelf weatherproof boxes, and the local guys did the installation, mounted the boards, drilled holes, made up cables. They loved it. They really did. And it encouraged me to try and do some more local manufacture, maybe some soldering and stuff next time. The thing is, these guys, they have to buy in everything, and they have to buy, you know, cheap stuff that doesn't work or breaks. It gets thrown on the junk heap afterwards. They don't have the skills to repair it. So the idea that they're empowered to actually build even a little bit of it, you know, the physical assembly, was just so fascinating. These guys are street kids, basically, with a couple of years of primary school education. But they just took to this project and loved it. And it's one of the big surprises of this project was how popular the project was with the people working on it. You know, let alone the technical and end users, just the guys who did it really loved it. As an example, these guys had earned probably $200 a month, and that's fairly well paid. And they sleep on the floor, this floor here. They get their board included as well. Probably eat rice 3 times a day. A mast is important for Wi-Fi because it's line of sight. And we just happen to have quite a few masts. They do have a little bit of water absorption, but they use anything. These guys are taught to climb coconut trees from a very young age, so they're really good at scaling masts and coconut trees. They're not very good on safety. I couldn't get them to use harnesses or anything like that. They just laughed at me. But up they went again. And They really liked this day because the guy was so happy with his mashed potato, he let them have as many coconuts as they liked. So they got their lunch as well. So here he is climbing. He's got a mashed potato in his hand, some cable ties, and one of the things the mashed potato does is the power goes up the phone line. You don't need another cable for the power, so that's just one wire there for the power and the phone signal. Here's another typical installation, just on a wooden stick, a couple of metres above someone's home. We've had pretty good results. As I said, we put a lot of work into making them robust to environmental conditions. A lot of tropical storms in this area, but things have been sticking out like this for a year or two now, and we haven't had any fail in the field except for software issues, but nothing to do with the hardware blowing up. And this is what it's all about. This guy, a gentleman called Arce, he runs a internet cafe where you can use the internet and Dilly print things out. But we trained him to install mashed potatoes, and he's got pretty good at it. And he's just installed a mashed potato for this lady. She heads up a NGO that specialises in women's rights in Timor. Women have had a particularly bad time there historically, so she helps champion their rights. She's the director, and she's making a free phone call, and that's why she's so happy. And it's a real practical issue for these people. So there's no landlines, there's no PABXs, so you can't even call the next office without a mobile phone, paying a couple of hours' wages. So this particular organisation has 2 or 3 offices across town, and they're using the mashed potato just as a PABX, really. It's only going several hundred metres, but it saves someone doing a 5 or 10 minute walk each time they need to send a message. The ability simply to pick up a call and make a phone call for nearly free is something we take for granted, but these guys, it's been a real tax on the way they do business. And if you're wasting money on GSM phone calls, a couple of $100 a month, your budget might only be $500 or $600 a month for the whole organisation. So that's money that's being taken away from doing, in this case, good work for very poor women in Timor. And now that's money they've got to spend on other things that they're not wasting on telecommunications. That's why she's so happy. We have some sort of mapping applications that show where some of the nodes were installed. These green lines indicate the paths that the mesh network has automatically worked out. That sort of changes dynamically as conditions change. And if you click on a node, it gives you sort of packet loss statistics, the signal strengths of nodes. And this can just be used to debug nodes. If you find red means this is a bad link leading out to this a segment of mashed potatoes here. So you'd do something about repositioning it or putting in a directional antenna, perhaps just for that link, to strengthen that link.
So you're right in the middle of the capital.
Yeah, yeah.
And the president, like, that's the White House of Timor?
That's the president. Yeah, that's the White House, and it is white.
Okay.
Yeah. Yeah, and there's a few more out this way that we haven't connected to as well.
What's up with the black nodes?
They have no connectivity.
I'm pretty late.
Yeah. In fact, I didn't know where they were because I wasn't a local, so I just pushed them off to one side. Yeah.
What is the density then? You say cell phone technology exists there, it's just the cost. What is the density of that? I mean, 1 in 100, 1 in 1,000, 1 in 10?
No, it'd be less than that. It'd be 1 in 2 or 3, I think, the cell phones. They've all got them. They just can't afford to use them. It's a status symbol. This is something that's interesting. Everyone has to have a cell phone, but usually it's only for incoming calls. Or they'll have a $1 prepaid credit card on it. Yeah, so everyone's got one. They just can't really afford to use it very often. Yeah.
So no, that they have the need to communicate, and they know what it's like to communicate, and so now you're making it to them cheap.
That's right. That's why they appreciate this so much, because they all know they're being taken advantage of by the phone companies. And some of the policies the phone companies use are predatory, like they sell handsets very cheap, $10 or $15 for a GSM handset. So you start using it, you get a bit addicted. And there's statistic in Africa, I think 60% of people's disposable income is spent on mobile phone calls. And that's of the poorest 10% of the country.
You're going to get some pushback from the cell phone companies, aren't you?
Yeah. Probably. But there is also some opportunity for working together. As I said, a lot of cell phone technology doesn't scale. So we're talking to people, our Chinese partners are talking to China Telecom, which is the largest cell phone company in the world. There's some villages they can't afford to go to, but they can get to the edge of it with data, and then they could use the mesh potato technology, the mesh network, to move it through that village of, a couple of hundred people. The interesting thing is, though, the cost of the calls, it's purely what the phone company decides. Places like China and India, they have reasonably priced phone calls, but a lot of poor people. It's just some of these countries decide to make the phone calls expensive. Often it's because the government, it's no other way the government has to make income. If you're a very poor country, there's no taxation base, there's no income tax, but mobile phone calls are a sure way to make money and take a lot of money off the poorest people, unfortunately.
Is there any kind of connectivity for, I want to say, like the equivalent of a 911 service for police or anything like that?
In this network?
Yeah.
Not specifically, although it is used by the police in many places. Yeah.
Now, the amateur satellites over Indonesia are totally useless because every VHF channel is used by somebody, by a ham radio they bought in Hong Kong. I mean, did you see any of that? In other words, are there people running around with walkie-talkies communicating?
Didn't see many walkie-talkies there. We did have problems. There's a lot of other Wi-Fi traffic around because there is no landline infrastructure. If you want to move a piece of data a few kilometres across town, you need a mast and a Wi-Fi link. Yeah.
When you see those red nodes, are you training people to do site surveys and how to react to that?
Yeah, we are working on that. That's sort of one of the problems I guess we haven't quite solved is if you get this red node, exactly how do you fix it to make sure you guarantee you fixed it? Currently we're looking at taking some off-the-shelf 5 gigahertz gear just to make sure we've got a good strong link across town and use this for the last couple of 100 metres or where there's no interference. The issue is it's got to be something that anyone can do with a few hours training. Yeah, so even training them in site survey software and things like that, that's sort of like a week's training probably to understand all the principles. And they've got to be able to read English. Yeah, and simple English, not technical English.
This is a suggestion. If you use your mashed potato with, let's say, different set of software hooked up to your laptop, you could use it as a test supply device, which kind of keeps your hardware cost at whatever it is right now.
Yes.
And you get your more or less free local device that can be used by somebody traveling around with a laptop, seeing if you have reception at this point.
Yes, we did do a little bit of that. For instance, we've got a spectrum analyzer software that runs on the mesh potato and gives you a plot of used Wi-Fi channels, and there's some other statistics we can extract out, like signal strength and surrounding nodes. But yep, that's a good idea. So, some of the surprises. The reason we do these sort of beta tests is you want to find out what you didn't anticipate and what assumptions you got wrong when you cooked up this idea in a meeting room. One of the problems we found was how bad Wi-Fi interference can be. There is a lot of Wi-Fi kicking around Dili. As I said, there's no landline, so the only way to move data across town is with a Wi-Fi link. So we had problems with Wi-Fi interference.
So this is all ad hoc networks?
Yes. Oh well, the other networks, it could be point to point, but they're using
Ad hoc.
they're using 2.4 gigahertz, so it's the same spectrum. Yeah. The killer app for VoIP was local calls. When we first did this, the idea was that it'd go through some sort of gateway into the internet and make long distance calls. But when we presented this idea to the local Timorese guys, they said, "Who are we going to call outside of Timor? We don't know anyone." So what we really want to do is just call 200 metres down there because I don't want to use my cell phone.
You're using what frequency band you use?
2.4. Yeah.
No 5 or anything like that?
Not this hardware, but we're using that for some of our long distance links. Yeah.
Is it interconnected with the cell phone so you can call?
We can put gateways in, but as I said, one of the surprises was they weren't interested. When you do interconnect with the cell phone network, you've got to start paying cell phone prices. They're all carrying cell phones anyway. They just can't afford to use them. So it's easy to pick up and use that if you need to hit the cell phone network. Yeah.
Is the cost of the standard telephone, you're still using the standard telephone, is that down to like $5 a phone now?
About that, yeah. We got them for about $4.50. Yeah. We have the benefit of working with Chinese mass manufacturers, so they walk down the road and get a crate for $45.
But it's still got to run on a 20 milliamp.
Yeah, and our mesh potato supplies all that, the 48 volts, the ring voltage. It's a similar chipset to what's used in ATAs.
But is it doing 48 volts at 20 milliamps? That's a lot of power.
When you take the phone off hook, the voltage drops. It's 48 volts when it's quiescent. Yeah. Yeah. So we found the killer app is local phone calls. Okay, the ability just to call down the road or across town. And that was really counterintuitive because we use VoIP for long distance, right, for cheap. We've forgotten how wonderful it is to be able to pick up a phone and ring across town or ring a few kilometres, but these guys just couldn't do it until now. So it's just using VoIP for local phone calls. They found a lot of value even in partial functionality. There were some cross-town links we couldn't do, like off past the presidential palace there, but they didn't care. I mean, I was really frustrated that this thing wasn't working 100%, but they said, no, it doesn't matter, we can still use it here, here and here. So they have this sort of patience and they perceive the value in just partial functionality. Whereas we go nuts if the phone call won't go through. We think there's something completely wrong. To them, each phone call is like a valuable gift. You have to get yourself into their headspace that this is 2 or 3 hours wage every phone call. You're giving to them for free every time they make a phone call. That's why they smile so much when they use this thing. The ease of installation was really good. We managed to get the point where no first world guys were involved. Those photos were all done, those installation photos were all done without me being around or the team that I went with. We even had second generation training where the people we trained went and trained other people who started installing networks in other villages. So that's really cool. That makes it viral. If we can just pump the hardware in, this thing, there's no limit to how big this thing can get. Yes.
Language barrier?
The guys I work with speak English, and we kept it pretty simple. Then they go into the local language from there. They were translating as I was doing the talk
You have
course.
some local people that speak English.
Yeah, we were working with the Fongtil guys, who were all fairly well educated and speak. They all speak about 5 languages, but English was one of them. Yeah. Sorry, was that a question? Yeah, that's our next step. But we're still sort of building up on the village scale at this point.
Have you considered other services that might go over the entire Wi-Fi mesh?
Yeah.
You have a relatively large available bandwidth.
Yes, we do. Yeah, it's basically the whole thing runs on VoIP. It's an IP network as a backbone. So we originally thought the usefulness for this network might be also just having a free local backbone across, say, a city like Dili, which is about 500,000 people. The reason that's useful is that at the moment, any internet traffic goes up to a satellite via a VSAT terminal first. So if I send an email to a guy across town, it goes up to a satellite, down to Indonesia, back up to a satellite, back down to another terminal a kilometre away. And that's at $5 a minute or hour or megabyte or something, really expensive. So we're thinking of using this as a free local backbone that anyone can jump onto and sprinkling Wi-Fi around town to do that.
Where do you get your funding?
The original project was funded by the Shuttleworth Foundation to develop the technology. Then I got funding from the ISIF and the ISOC, both internet advocacy organisations for the developing world for this particular rollout.
Will there be a sustainable business model that will keep this network going?
Coming to that.
Okay.
Yeah. Yeah, okay, so the other point was the project was very popular with the Timorese. The end users loved it and the guys installing it loved it. So you've got a product or an offering here that people love to use, both the guys installing it and the guys using it. So that's pretty good. They're those human factors that no matter how good the technology is, if the guys get frustrated using it, they're not going to be inclined to deploy it. But if people love using it and installing it, that's a really good step. So the outcomes, this is back in January when the project officially finished. We had deployed 70 nodes. There was demand for more. Very easy to set up. A few problems with mesh links. We had Timorese training Timorese. We had examples of this thing being installed across a valley on 2 sides of a village where it saved a 3-hour walk. There was line of sight was only a kilometre or 2, but it was 3 hours to get through this rugged terrain. So that's what a phone call can do in these places. And if you've got to do a 3-hour walk, that's 3 hours you're not doing valuable economic activity in the day, earning an income. It's being used to connect rural clinics, police, ambulance, NGOs, things like university IT support. It was very useful between 2 campuses of a university. You can't do IT support on a timed phone call. If you've got to sit there for 20 minutes and tell someone to click on their PC, you can't be watching the clock. You need an untimed phone call service. So it's things like that it was useful for. It's really helping people every day. One thing we needed to do was landline training. A lot of people had only used mobile telephones, so when they saw a landline that you've got to hang up, we had to explain to them, put the phone down when you're finished. There's no off button. So, what worked in the project? Ease of setup. We put a lot of work into making it really easy, and that worked. The training worked well. There was a bit of popular demand for some other villages, some rural towns, so we expanded it there, just smaller networks, but that was good to see. End users were happy, and there's strong demand for expansion. One thing that never surprises me is you really can make phone calls over it. I'm an engineer, I build technology, most of the time I'm dealing with the bugs in the things I've built. So when I'm sitting there one day and the phone rings and people are making phone calls over it and it works, it doesn't just fall over and die, I'm sort of never cease to be amazed. Yeah. Back of my head, I think it's just going to stop working one day. But it really can make phone calls. What went wrong? Nasty interference, particularly in Dili, where there's a lot of other, larger city, a lot of other Wi-Fi going on. Usual schedule slips. The ease of use breaks down in some cases, such as the interference case. And as your question indicated, we need some really turnkey way that says, okay, this link's not going to work. Here's what you do. Put up this new antenna, point it this way, wait till the red light goes on. So we need some real turnkey way to set up problem links. There's a little bit of reliance on third-party hardware for those long-distance links. The mesh potato is good for the short areas. We built that, we control it. We control how long it will be manufactured for in its specifications. But we use some third-party hardware for the long-distance links, and we don't have that same control over the hardware. Also, local calls means no business model. We'd originally planned someone would be selling long-distance phone calls through this and making a margin of a few cents a call. The calls would go out via voice over IP. But because local calls are so popular, at least in Dili, we don't really have a business model. So we're searching for a new one. That might be a subscription type model. Someone might pay $1 a month to have one at their house, and then the guy will keep maintaining it, for example. In other parts of the world, Dili is just one rollout. There's now many. The long distance model is working, and people are using that as the business model to sustain the system. The other business model is a lot of people just like it from a community point of view, and they're willing to put up $100 for a mast and a mesh potato to get a phone in their house. So it might just be sustaining from that sort of way. People like it enough to the local community will pull together to install these things. But we're still sort of searching for the final answer on the business model, I think.
When you talk about the business model, it kind of seemed like you would let that be decided by the local person running it, but you're also, is it you just suggesting ways that are profitable? Yeah, we feel there needs to be a business model because we don't want to rely on charity long distance. Sure, but is the ultimate decision on the person? Yeah, but what we want to do is come up with like a turnkey system that we can roll out in many other countries. Look, this is what will work. So that's why. But yeah, sure, the first place we ask is what the local guys, what do you think will work and what won't? Yeah.
We don't have any payphones in the United States anymore. Okay. So do you see some of these phones being put in this guy's house?
Yeah.
And everybody within 50 feet.
Yeah.
They all use that same phone?
That'd be a business for someone. You wouldn't automate it, you just have his mother sitting there taking 5 cents a phone call.
Well, you can tell him about a payphone being a person in most of the third world. Is if you want a payphone, you go to a guy whose job is to be a payphone, and he takes your money and lets you use his mobile.
Yeah. Yes.
Now, this being open hardware, open software, and somebody basically setting up a business, having them running, and these are some countries where a lot of stuff is being cloned and copied and reproduced. How far would he have to fear that after he put the money down and set up his business, somebody within the area will basically set up his own equipment and parasites on this?
It's a good point, and I don't really have a good answer for that. I mean, as far as I'm concerned, the end users get telephony, so I'm reasonably happy. But yeah, that is something we'll need to deal with. Yes.
Are you familiar with Kiva?
Yes.
It seems to me that might fit as a business model for funding some expansion to this.
Yes. Yeah, a friend of mine works there, and we've got a few talks with that.
Right.
Yeah.
David, do you encrypt those links? Would that help? Would that help to encrypt the backhauls?
We could do if we wanted to. Yeah, it's sort of built into asterisks.
Talking about your parasites on the network.
Yeah.
Put a WPA key on there, and
now
that would protect your Wi-Fi investment.
Yeah, that's a good point. Good idea. I personally learned a little bit about patience. It's very different to the first world. As I said, I experienced the power going off and being stuck there. I'd flown up to this place, especially for a couple of weeks to work on it, and wasted half a day waiting for the fans to start turning and all the power to come on again. But these guys just sort of kick back and they're just used to it. I found that there was usefulness even in partial functionality, which really surprised me, just being able to call down the road. They said to me about 1 in 5 of the technical projects they work on actually work, so we're pretty, we're up there already in the 20% range. And it's okay for them if it takes a few months. They're not in any real hurry, as long as they know how to do it and the power's in their hands to make this thing work, and that was the key thing for them. The future, this year the Timorese guys are continuing to expand. They're actually at the point where they're spending some of their own budget, and these guys have a budget of probably 15 grand for a department of 10 people for a year. and they're pumping about half of that into the Village Telco and expanding and buying more mashed potatoes. So that's when they're real believers in the developing world, because most of the time a lot of this is grant funded, but when they start spending their own hard-earned money, you can know you're really onto something. And I don't know if they've ever done that before for similar projects. So yeah, in the developing world, that's the biggest sign of success that we've had. It doesn't get any better than that. So thanks to the people who funded it, the ISIF and ISOC organisations funded the grants for the Dili Village Telco. Atcom, Chinese mass manufacturer of VoIP gear, who are making the mashed potatoes for us. The Shuttleworth Foundation from Cape Town, they supported the Village Telco. There's a big community of people who are involved in the Village Telco. It's an open source project. A lot of people contributing software and expertise. And thanks to TAPR for bringing me across here and giving me the pleasure of talking to you all. Thank you.
One more question.
Sure.
For maintainability, I assume you don't have any batteries in the system anywhere?
Any batteries?
Batteries, right.
Not inside the box, but it's 12 to 28 volts that you can put in it, so they can be battery operated, or you can connect a solar panel directly. They'll handle that high voltage. Yeah.
But it's not dependent on the batteries?
Not dependent on a battery, yeah. It would be a nice option to have, especially when they have rolling power blackouts across town. Sorry.
How do you handle the signaling? Is that done in the analog telephone adapter, or do you use the telephone instrument, DTMF?
Yeah, it's a regular telephone, so it just responds to, phone going off hook, dialing DTMFs. That's all decoded in the mashed potato, and that generates all the ring voltages. And
I mean, but then it telnets or whatever.
Then it's running asterisks inside the box, PBX software that runs on the mashed potato.
ATA?
Yeah, in the mashed potato hardware. It runs an IP PBX.
How many digits in the phone number?
Sorry, we just had another question here.
Have you come up with a practical limit to the size of your mesh network?
Due to Wi-Fi channel limitations and traffic, at a 10% activity factor, it's about 500 in one network. But then if you can start overlapping channels outside of that, like a cell network, you can expand it indefinitely. Or if you can have other links like Ethernet or other frequencies. Yeah. How many digits? We use the IP number as the telephone number. So 10 star 1 star 1 star 100. And you can just put in the last few digits, the last octet if you like. So if you dial 10, it'll dial 10.1.1.10. Yeah, because each mashed potato has its own dedicated IP. Yeah.
You must be making some powerful enemies.
Well, we talked to the Timorese government about this when we first installed it, and they're as angry as the telephone company as all the local people. So they supported us, and because it's a new country, they didn't have any laws on the books for voice over IP. So no, we sort of helping set public policy, I guess. Yes, out the back there. Yes.
An amateur radio question. East Timor has been a rare country in the few times it's been on the air. In fact, a few of the NGO people were killed there during the insurrection. Did you find any interest in amateur radio among these people that you were teaching a bit of technology?
I didn't actually talk to them about it, and I should have, I suppose, taken a rig across and made a few calls. I'll do that next time. Yeah, I imagine there would be interest, but the cost barrier would be there for most of the locals.
We'll send them some equipment.
I got some buddies of mine at the X Club, boy. They'd send them equipment.
Okay. Well, I can promote that next time I'm there. Yes.
Do you have a telephone book?
Yeah, they had a bit of paper stuck to the wall. One sheet. Yeah.
One sheet. So for future direction for this type of environment, do you think they're going to want to go in the direction of more of the cell phone wireless service, or do you think they're going to be interested in more of a broadband computer networking service? I mean, what's the next big thing for a developing area like this?
Yeah, they need internet as well, and they need broadband. The killer is getting out of the country.
Right.
Yeah, these sort of technologies we're playing with are okay for the local loop, and that's not too hard to do with off-the-shelf equipment. But how do you get it out of the country at a reasonable price?
Do they need to?
Yeah, for internet you do, not for telephone calls. Yeah. Yes.
You hinted that the police and other public services used
Yeah, one of our examples, we're linking police and public services. Yeah.
Do they seem to find it useful?
Yeah, before this, they're in an area where there's no cell phone coverage, so they're limited to VHF handhelds. So the only way you'd get a message, say from the hospital across to the ambulance station, would be transcribing it, if someone was listening to the VHF radio. Yeah.
Okay, so I'm gonna give David a break here. So Sheila, bring your camera. David, come over here.
We're not done yet.
We're not done with it yet. So but I want to present this. Oh my goodness, I've got it. Somebody switched plaques on me. Playing jokes on me here. So I want to present this plaque to you, David, for David Rowe, BK5 DGR, for being our keynote speaker at the ARRL and TAPR Digital Communications Conference in Baltimore in September. So thank you very much.